Alright guys, so welcome back to this channel, and in this video we are going to be considering the systems of linear equations. So this lecture is going to be um, in segments, right? So this is the first class. We're actually going to have the second and the third class where we're going to be attending to each section of this topic one after the other. So if you're new to this channel, I'd like you to click on the subscribe button, share, and also like, comment, and let us know what you feel about this video. All right, so let's dive into the video proper. The systems of linear equations. So when we say systems of linear equations, we have about two words that are there. We have the word system, and we have the word linear equations. If I can even break it to three words. We have systems, okay, and we have linear, as well as we have equations. So I would like to make it simple as possible. So what is an equation? What is a system, and what is meant by linear? So let me say this. An equation, for example, when we have 2x plus 1, this is a function of x, right? That means the only letter there is x, so it is a function of x. But once I can add an equal sign to it, maybe equals to something, maybe equals to 3, now it becomes an equation, right? Why is it an equation? Because it has an equal sign. That's the meaning of an equation. Do you get that now? So when we now say something is linear, linear means that, for example, if I should write 3x plus 5, okay, so if you check the power of the letter, what's the letter here? The letter here is x. So what's the power of the letter? It is 1. Okay, the letter has the power of 1. So for an equation to be a linear equation, it has to be that the power of the letter in that equation is 1. Is that okay? So the power of that letter is 1. So that's meaning of a linear equation. Do you get it now? So when we say something is a system, so let me call this one linear equation, like a straight line. Okay, that's why it's called linear. So when we now say system means that we are considering multiples of the linear equations. We are considering more than one of them. Okay, so we are considering probably two. We are solving simultaneously, like what we did in secondary school, where we have to solve simultaneous equation, two or more. So now we've been able to break down uh, the terminologies, like the keywords in the topic itself. So now, how do we mathematically write a linear equation? If I want to write it, because it can be more than one. So a linear equation can be written in this form: a1 x1, okay, plus a2 x2, plus the more you want to write, then an xn is equal to b. This is how we write a linear equation. If you see that, if you notice, all of my x, the power is what? 1. Power is 1, power is still 1. So that's how to express a linear um, equation. Now, this a1 here is a coefficient. It's called the coefficient of your variable. Is that okay? Why this b is your result or your answer. Let me just call it my answer. Is that okay? So that is a brief explanation about how to write a linear equation. Now, how do we write? Okay, let me give you an example. Suppose I give you an example now. Suppose I have number one. Which of the following is a linear equation? If I have 2x1 x2 minus 5x2 okay, plus 4 equals to 0. And number 2, if I should have, let's say I have x1 squared minus 3x2 plus 5 equals to 3x3. Now, which of these is a linear equation? Now, considering question, the first equation, you see that the power here is 1, the power here is 1, the power here is 1. And of course, x1 and x2 is not the same thing. I would have said x1 times x1, that's x1 squared, but they are different letters. So this is a linear equation because the power here is what? Of degree 1. But if you check out this second one, the power here is 2. We've had something more than 1, as the initial um, theorem has stated that for it to be a linear equation, it must not have more than 1. So this is not uh, a linear equation. Is that okay now? So that is what we mean by a linear equation. So let's move into understanding what is called a system. So I'm going to define it. So when I say a system, so a system of linear equation now. So a system of linear equation is a collection, okay, is a collection of what? Of one or more. It's a collection of one or more linear equations, okay, involving the same variable, the same variable. Okay, so it's a collection of two or more, like I've defined earlier. It's a collection of two or more um, linear equations that you want to solve simultaneously, and trying to attend to them one after the other is what we now call the systems of the linear equations. So why dealing with the system of linear equations? Of course, we are going to get answers. Okay, you are going to be getting answers. For example, remember in your secondary school where you have to solve linear equation, you have x, y, z. Then you have to get the value of x, the value of y, and value of z. Okay, now the value of x, y, z. Let me write it this way: the value of x, y, z. Let me say x, y, z, like the way you usually get it. Let me call it ABC. Now, those answers is called the solution set. The set of the answers of your linear systems of linear equation is called the solution set. So kindly note these keywords so that when you get to the subsequent videos for this topic, you are going to understand what I'm talking about by the time I start using these terminologies. So the set of the possible solutions of a system of linear equations is called the solution set. That's the list of solutions of a system of linear equations. Is that okay? So that's uh, that's another thing that we want to check out. So in the in a system, there are two type of system. Basically, there are two types of system. Okay, we are going to be saying this, but let me just mention them. We have what is called a consistent system, a consistent system, and we also have an inconsistent system, an inconsistent system, right? A system can be consistent and it can be inconsistent. So, what does it mean for a system to be consistent? It means that it has a solution. It has a solution, right? It has a solution. And when it has a solution, there are two types of solution that it can have. It can have a unique solution, or it can have infinitely many solutions. infinitely many solutions, right? So we are going to see that why we are solving. This video is just for explanations. Now, when do we say a system is inconsistent? A system is said to be inconsistent if it does not have a solution. Okay, no solution. So consistent system, it has a solution, and it might be unique solution, and it might be is an infinitely many solution. An inconsistent system is when there is no solution at all. Okay, so that's another terminology that we need to basically understand. So let's move to the next terminology for this class. Now, there's something called a redundant system of linear equation. A redundant. A system can be redundant. Okay, redundant. When we say something is redundant system, it means that um, if there's an invalid uh, arrangement, right? If the system is actually invalid corresponding to the answer, or for example, when we have a system where there is a repetition of a particular rule, well, we are going to see if we see something like that while solving, right? It's just when we have a tautology, when a system or a rule is not useful for the purpose of what we want to solve. That is what is called a redundant system. And the last one, we are going to talk about uh, the free variable and the basic variables. So when we say the free variables, let me talk about the free variable, let me talk basic variable and the free variable. Free variable, right? Now, when we say the free variables are, when we solve a system of linear equation, unlike, we say we have two types of solutions. It can be infinitely many or consistent or unique. So when it comes to free variable, you know, when it's a type of infinitely many solution, we are going to have some free variable. What are free variables? Let me just give you a classical definition. So a free variable is a variable that does not correspond to a colon with a pivot. What a pivot is, we are going to say it in the next class. So don't forget to turn on your notification button once the video drops so that you can get notified. Okay. Again, a free variable is a variable that does not correspond to a colon with a pivot when the matrix is in a row echelon form, right? While a basic variable, the definition is a variable that corresponds to a colon with a pivot when the matrix is in row echelon form. All right, so that's going to make more sense while we are solving in our next video. So, guys, don't forget to like, don't forget to share, and don't forget to subscribe to this channel because we're about to drop more exciting videos and more educational videos that will help you in your exams. And also tell your friends about this channel to in other schools. Until then, and I would like to see your comment on this video in the comment section below. Until then, have a good day.